Hello mga ka-Super Science! Welcome to another amazing week of learning. This week, we will learn about forces and motion. So without further ado, let's start! The most essential learning competency for Quarter 1, Week 2 is infer that when a body exerts a force on another, an equal amount of force is exerted back on it. In the previous module, you have learned that force enables objects to change its state of motion. If an object is at rest, moving it requires force. For an object already moving, changing its velocity, either in magnitude or in direction, also requires a force. So, what is the exact relation between force and motion? For centuries, this question had confused philosophers and observers of nature, including this Greek philosopher. He is Aristotle. He believed that a moving object needs a continuous application of force to keep it moving. So, Aristotle's ideas made sense because they were based on most common everyday experiences. There are still scientists and great men behind the concept of force. But in 1686, this scientist formulated the three laws of motion, for which he is most famous. He is Sir Isaac Newton. The three laws of motion are the law of inertia, the law of acceleration, and the law of interaction. These are certain concepts that explain the nature of how force and motion interact. And we will go through each of these concepts in this lesson. The law of inertia. Newton's first law concerns objects at rest and objects in motion. You are all familiar with the fact that nothing in nature will start by itself. For example, a stalled car must be pushed to start its motion. The first domino piece must be pushed so that the others will move. The first law is also applied in pulling a tablecloth very quickly without dislodging the dishes. When the tablecloth is pulled very quickly, the pulling force is unable to act on the dishes. Hence, the dishes remain at rest. Those example situations are due to inertia. Inertia is the property of a body that tends to resist a change in its state of motion. The measure of inertia is mass. The greater the mass of the body, the greater its inertia. Meaning, an object with more mass has more inertia, and it would take greater force to move the object. In summary, the Newton's first law of motion states that an object at rest will remain at rest, and an object in motion will remain in motion unless it is acted upon by an external force. The second law of motion is the law of acceleration. The second law states that when a net force acts on a body, the body will accelerate in the direction of the force. It means that acceleration is directly proportional to the force while inversely proportional to the mass of an object. This can be expressed in equation form as A is equal to F over m, where A is the acceleration, m is for the mass, and F for the force. This is often rearranged as total net force is equals to mass times acceleration. Like any other quantity, force has a unit and expressed in Newton, or capital letter N. 1 Newton is defined as the amount of force required to give a 1 kilogram mass an acceleration of 1 meter per second square. Or simply, 1 Newton equals 1 kilogram meter per second squared. In summary, the unit for mass is kilogram, acceleration, meter per second squared. In force, Newton or kilogram meter per second square. So, wag kayong malilito sa mga units, okay? So, let's have a sample mathematical problem. Number 1. A 1,000 kilogram truck is traveling at an acceleration of 4,500 meter per second square east. Find the net force needed to accelerate the truck. So in solving the problem, let us first write the given value. So we have
an acceleration of 4,500 meter per second square is, and a mass of 1,000 kilogram. Then we are looking for the total net force. For the equation, we have the total net force is equal to mass times acceleration. Next, in solution, we need to substitute the given value. So we have total net force equals 1,000 kilogram multiplied by 4,500 meter per second square. So the answer is 4,500 kilogram meter per second square, or 4,500 Newton is. Very simple, right? So let's have another example. For sample problem number 2, a boy rolls a 200 grams baseball horizontally on the floor with a net force of 2 Newton to the right. What is the acceleration of the baseball? Again, in solving a problem, isulat muna natin yung mga given value. So we have the mass of 200 grams and the total net force of 2 Newton to the right, or 2 kilogram meter per second square. So take note, if the given mass is not in kilogram, kailangan muna natin siyang i-convert. So we need to divide the mass value by 1,000. So 200 grams divided by 1,000 is equals to 0.2 kilogram. So we need to find the acceleration. For the equation, we have acceleration equals force divided by the mass. In solution, again, we need to substitute all the given value. So we have 2 kilogram meter per second squared divided by 0.2 kilogram. Next, we need to cancel same unit, which is kilogram. So ang matitira ay meter per second squared. So the answer is 10 meter per second squared to the right. So move on na tayo sa third law of motion, which is the law of interaction. Do you ever wonder why you can jump off the ground despite gravity always pulling you down? Ito talagang si gravity, hilig magpa-fall. When you jump off, you are applying Newton's third law of motion, the law of interaction. The law of interaction states that for every action, there is an equal and opposite reaction. Sana all may interaction. Wow! This law explains why you can jump off the ground. When you jump, the ground gives an equal amount of push toward your feet that pushes you up. Newton's third law of motion has many applications. For example, while walking, we push ground backwards. As a result, the ground pushes us forward. Also, hammering a nail and pushing a grocery cart. Interesting, right? So that would be all for the 3 laws of motion. Can you think of situation where law of inertia, acceleration, and interaction can be observed? Write your answer in the comment section below.
At dito na nagtatapos ang aking video lesson. Thanks for watching and see you again next week for another amazing videos. Don't forget to like and subscribe to our channel, the Bataan Science Channel. Goodbye!